everyone. A very warm welcome to what promises to be an eye opening session. Now, when we usually think of webinars, we imagine slides, stats, and a lot of tech talk. But today is different. Today is about the story behind the tech, the journey behind the job title, and the person behind the LinkedIn profile. So, gear up. Who knows? This might be the turning point in your career. On behalf of ACEC, I'm thrilled to have you all here. And while it needs no introduction, ACEC is that little spark within our department that tries to lit bigger fires. It's the bridge between classroom chalkboards and the ever evolving tech world, where the future is being built one innovation at a time. Now, I would like to welcome our chapter coordinator, Professor Shubham Pramanik. Professor Pramanik has been a very active person in coordinating our students' chapter to the peak where it is right now. And we are honored to pass him the mic to introduce our respected guest speaker.
Yeah. So on behalf of IEI Student Chapter and Department of Electronics and Communication Engineering of Academy of Technology, I extend a warm welcome to you all to today's insightful and inspiring session, Preparation for Next Level Jobs in Technology. We are truly honored to have with us the distinguished alumnus of our own institution, Mr. Sumit Kumar Dey, who have carved out an incredible journey in the field of cutting edge technology. Mr. Dey is currently working as a senior software engineer in autonomous driving at NVIDIA, based in Berlin, Germany. A position that stands as a testament to his deep expertise and global impact. A 2014 pass out from the ECE department of AoT, Mr. Dey went on to pursue his masters in artificial intelligence, specializing in computer vision and robotics. His work focuses on high performance systems for autonomous vehicles with research experience in sensor fusion, navigation, and perception system. Today we get a chance to learn from his expertise, insights, and strategies. So we will have a session where we will know this directly from someone who has walked the path from student to global tech leader. So please join me in giving a warm virtual welcome to Mr. Sumit Kumar Dey.
Expectations is that regarding preparation for next generation careers, why this talk is happening is because okay, first of all, because sir asked me to, I have an assignment even after 10 years of passing out. But the part that I want to highlight here is that we are not talking about any industry here. We are talking about state of the art industry. And what does it mean? Many of you may know, many of you may not know the word state of the art. And state of the art is usually used in scientific research to show that what is the limit of human knowledge at this point of time. And we are talking about going to that kind of industry and how to reach that kind of industry. So do not expect that there is a clear path already available for you. Like, for example, I appear gate, get a qualifying marks, and then I go to a certain place and I will be there. It is not like that. It is little bit more vague. So please keep the expectations a little bit on the lower side, that it is not going to be, I can give you a pointer that, yeah, if you do this, you will definitely reach to this place. But I will try to provide you some guidelines of how to become an engineer who will be successful in the state of the art industry. And with that, the first thing that comes to the mind is that what the exposure of that industry, because what we study in our universities is basically the foundations. But between the foundations to the state of the art, there is a large gap. And of course, you have to study the foundations, but after that, you have to do a little bit of your own work to bridge the gap to reach to that level. And this is why I want to give you the exposure that what is the latest thing that is going on in the tech industry, not going on, but also give you a complete picture of what it looks like. So I'll start with, let's go ahead. So I put up some videos for you to show that. So I do not have any media from my days in college, because in AoT, because I did not have any smartphone at that point of time. I had small bar phone, which, yeah, only served for calls and SMS. So I do not have any media, unfortunately, of that time. But in same year, I think this is a friend of mine who made this video, where we made a robot to play some sort of, ball returns. The idea was to play a tennis, but I was not there long enough to make it play a full-fledged tennis. But this already had almost all the basic elements in it for anyone else to develop on top of it. This robot that you see here on the top is a Barrett worm. It is a 7DOF manipulator from MIT. And yeah, we worked with it. How it works is that on top there is a camera, and you need to calibrate the camera's workspace, what it sees, with the manipulator's workspace, that where manipulator can actually work. So it is a very simple part, but the amount of mathematics that goes into it was incredible to just do such a simple thing. Okay, so let's go to a little bit next one. So here I already had my own smartphone when I was in studying masters at Q11. Well, I had to, because I could not call home otherwise over the internet, and SIM was very expensive. So here, what you see is this is the personal robot 2. This is the world's first personal robot. There was a personal robot 1, but it was not a large scale success. There were some issues, and this was the first successful personal robot from Willow Garage. And as you see, it is marked with the university, because university actually contributed towards it. There are a couple of other things that here are interesting. This is an exoskeleton. This is also a robotic equipment, but this is an exoskeleton, means somebody can wear it on their body. And the part that we are seeing here is just the legs and the hips. You can see here, this is sitting here. This is to allow people with who cannot walk, or for some reason, it can assist them to walk. But the interesting thing is that it is not a manual thing. It is an electronic thing. What it means is that it can take signals from the user's body, and if the user wants to move their leg, the neurons fire in a certain way, and those can be that is I think most of you may know it. It is called electromyography. You can tap it on the muscles for those signals, and once you can determine that that this muscle signal is meant for certain activity, like stretching the leg forward or backward or something like that, you can then use that signal to trigger the corresponding motors to make that activity happen. So for a person who is using it, he does not need to do anything with a remote control or fiddling with the switches or anything. He just needs to be able to just think or try to move their legs, and the signal is enough to make the motors or actuators in general, because there are both linear and rotational ones. So the actuators to function to make the person walk, and also to sit straight, because it is also for a spinal injury, so lower spinal injury as well. So this kind of things. It also is very important for old age as well. This also functions very nice. It also has some fail safe and things like that. It is very cool little equipment. Some clips of my desk there. So this is what I worked on the lab. This is not from me, but it is also something very, very cool to see that there is this it was supposed to be a quadrotor, but quadrotors have the intrinsic problem that they do not have very high lateral velocity. So they cannot go sideways very fast. I mean, if you see it, you can say fast. Fast is of course subjective quantity, but we can go faster. And for that, this kind of aerodynamic shape is very helpful. And this aerodynamic shape, like a plane-like thing you can see, also provides a lift or the up thrust. So let me show you this. This is a RViz simulator that you see on the screen. This is a little bit old. New ones will look a little bit better. This and also the UI part of it that you see is of course changing as per the scenario and as per your configuration. But those of you who are interested, this is an open source software. This is part of ROS, Robot Operating System. You can download it and use it. You just need the data. You don't need to be on the live vehicle. I think many of us have this confusion that probably you need to be on the vehicle to get this. But basically, if you have all the sensor data, you can run a robot operating system. Robot operating system is available on Ubuntu. So you can install it there and you can play with it. And then you can monitor that how things are going and so on. You can also develop your own algorithms for sensing and planning and control and whatnot. You can do a full development of an entire autonomous vehicle on robot operating system. And this is what we were using there. Yeah. So this was our test vehicle, and we had built it ourselves. Every part of it was built by someone or the other from our team. So just to tell you that behind all of this nice graphics and video and so on, the part that is actually working here is something that you have the capability to do it, or you have the opportunity to do it. The hardware is not the limiting factor, or hardware, by hardware I mean the car, and all of the other things is not the limiting factor. It is just when you want to deploy your algorithms in the software, then you are already able to test it on this simulation software. But if you want to test it for certification or something like that, at that time you need a vehicle. So most of the work is done outside of the vehicle. So you will notice something very, very interesting, that this is the difference between a production vehicle like this one and a ordinary development vehicle, is that you need to already assess what is in the environment and what you need to do before it already happens. So it is probably very easy to see that if there is obstacle here and then stop. But we need to have predictions that, okay, there are people here who are likely going to come onto the road, and you have to stop beforehand. You cannot wait for them to come here and cause a unwanted situation. So it already stopped. So these kind of algorithms which do this kind of predictions, I'm not sure, depending on which year you are, you will probably already learn in your BTech itself. One of those algorithm is Kalman filter, which does the prediction. Of course, you go a little bit more serious multimodal distribution kind of things that you want to do prediction in a safety critical environment. But the basic algorithms you will already learn in your BTech itself. So it is very important, and I will also tell you later about it, that most of the time what happens during our studies is that we learn something in our as a part of our semester's courses, and then we kind of remember it, we kind of go to the exam, we write the exam, and then it fades away over time. And the fading usually happens when those knowledge are not grounded. And by grounding means that, do you have a connection with the real world with that knowledge? And the best way to do it is that when you learn something, see what are the practical applications available. Usually, what I used to do during BTech, it was not possible to do for everything, but I used to have my some mini projects. I used to try something, develop something, and try to play with it. And once I am playing with it, I am already exploring the boundaries, limitations, and whatnot of it. And that that part actually stays more than the lectures or the theory part of it, at least for me. Yep. So I can highly recommend you to actually do that, because many of the things that you are seeing here, um, um, in a refined and polished way, most of the fundamentals are already available with you.
So Ayush Mondal is saying that what are the sensors that are used in the cars, this type of automated cars?
There are several sensors that are used. So most commonly are cameras. Cameras are always there. There are ultrasonic sensors for near field parking. So ultrasonics do not have very long range, but you need long range sensors for high speed cruise control, adaptive cruise control, for example. For that, you need radars, which are narrow and very long range. And then you need a surround view system, and those are a fusion of lidars and also cameras. So these are mostly the essential sensors there. There can be some more sensors. For example, there are some high frequency sensors like IMU for accelerometers and gyroscopes, to know that how the vehicle is behaving in the short term, and also for acceleration, for actuation of the vehicle in general. You also have a GPS, of course, and the GPS is not the same as the cell phone GPS. GPS is a differential GPS, which has a little bit higher accuracy, but your cell phone GPS would also work. We have made autonomous vehicle run with 1 second latency of GPS as well, so that also works. Yeah, and then there are normal ordinary sensors that a vehicle already has. So for example, odometer is already there in the vehicle. Those are used for calculating the ticks of the revolution of the wheels, and also to detect that if the traction of the wheels are correct. So, for example, if one of the wheel is slipping, the vehicle can go into a undesirable state of like unstable state where the vehicle moves away, and you want to also control it. So those is like electronic traction control. For those, you also have those things, but those things are already present in most of the modern cars already. But those are also used for the fused working of the autonomous vehicles as well. So apart from the ordinary sensors that are already there in the modern vehicles, you have radars, lidars, ultrasonic is also there in the modern vehicles as well, and cameras are a little bit more sophisticated than ordinary dash cam cameras. Yeah.
And we have another question from Reek. He's asking what is the purpose of this research which is already done by Tesla?
Okay. This is not research. This is production. So Tesla is one company who does it. There are many other companies who also want to do it. Tesla is and probably this is also something that needs to be known to us as engineers a little bit differently than the mass media general public. So Tesla does not do level 5 autonomy, right? It is not possible. So there are levels of autonomy. We will also see to it, and I will show you those things. The goal is to reach level 5 autonomy, where you do not need any of the artifacts of the vehicle, like steering wheel or brake or accelerators and so on. And the choice how you do this complex solve this complex problem is also will also vary from one group to another group. For example, Tesla does it with cameras only, which of course is little bit makes the computation load lighter, because lidars and radars have very high computational load because of the immense amount of data bandwidth that is required to handle those. Uh, and Tesla does it with cameras only. So for a fine day, bright lights and so on, even at night, this is going to work good. But when there is a fog or smoke or things like that, their cameras have the inherent drawback that they cannot see beyond it. And those challenging scenarios will be very difficult for Tesla. There are test scenarios where Tesla has been used with the fog and smoke, and Tesla does not even brake. And I do not know if you are up to date, but there is also a litigation against Tesla on that. Because Tesla cannot brake before an obstacle because of smoke, it could not see it, and it is in autopilot. Just before it hits the obstacle, it removes the autopilot and makes it into manual mode, so that they can claim that, oh, it was not in autopilot, it was being driven by the driver, and then the driver has to prove it otherwise, and so on. So this kind of things are happening. But yeah, I'm not going into that kind of discussion. The idea is how Tesla does it is, of course, their business. How Mercedes will do it, it is their business. How Jaguar will do it, it is their business. How BMW will do it is their business. Everyone makes cars, but they have their own expertise and their own excellence. So even without all those drawbacks that I mentioned before, to off-road on the car for that purposes. And therefore, there will be variations and things like that. And between you and me,
There will be a question answer session shortly after
yeah,
this. So I think
yeah.
we'll have to wrap it up here. I mean,
Okay.
many
Then yeah, let's
questions
stop
have
it.
been
Yeah,
asked. They
yes,
want to ask
let's
you.
yes.
Uh, I am asking ACC members to put those questions.
Yeah, sure, sir. The questions are in the Q&A section. I'll be reading them out.
Yeah.
Okay. So we have a question. What skills are most in demand for a career in VLSI and fabrication? This is probably from the fabrication part that you were telling me about.
So I am not directly involved in fabrication, so I will not be able to give the best answers here. But for now, if you want to pursue that field, you need to know VLSI. Maybe play with risk. Try to develop something very small, add on top of risk. You have the open source hardware available. Get involved with it, and once you are in that open source community, you will develop a lot of contacts from there to how to go further into this topic. You will also find so if you are planning to go for higher studies, you should look for the universities which provide semiconductor courses and have a industrial counterpart of it, right? So not just the university by itself, but they also do research, high-end research into it. Look for photonics and quantum computing. If they also have that, this will be very nice. Photonics specifically, if you are trying to be little bit conventional, photonics will be very good. And yeah, I think that is all I can do. And if you are still interested, and if you have done something, you can write to me. Probably my contact details will be shared with you, and I will be able to connect you to the top of the line research of semiconductors directly.
Okay, so we have another question that is again for fabrication. What are the biggest challenges in the current semiconductor fabrication processes?
Well, the challenges in each of the steps that I said, it is enormous, right? So if I have to name something on the top, so from the top, for example, DRAM. The DRAM construction is extremely difficult because it is highly skewed construction. Yeah, so you need to have a capacitor. The capacitor has a aspect ratio of 25 times of the Burj Khalifa. So Burj Khalifa is very tall. You have a very short base and very big height, and think of it as 25 times of that aspect ratio that goes into the DRAM currently. And you cannot fit it in one silicon wafer. You need two silicon wafers, and then you need to join those silicon wafers together. This is one of the very challenging scenario to make a very good memory or high density memory for every task. And we want to move the memory from the external to internal. We want to have the memory inside the silicon itself. And the cache memory and things and shared memory are already there, like cache memory for CPU and shared memory for GPUs. These are already there, but these are taking very huge spaces. And if you can shrink those down, that will be an immediate bonus for everyone. And then it comes to photonics. Almost the whole industry is going towards photonics. We already have data centers which makes the interconnect with photonics, because cable wires are slow. So we have light based interconnects also between inside on the motherboard. So for example, Blackwell CPUs that NVIDIA has released, the interconnects between two CPUs are also photonics. So they do this. So the next part is the logic based ones that I told you is in development, but you can pursue it further and make it the go-to part, and we can move away from silicon and silicon based and go to passive light based. Light based ones, current change is the size. The wavegates are of much bigger size because you have certain wavelengths to support for those waveguides. So those are the current challenges. Also the laser, the transducers to make the data inflow there. There is lots of challenges. I can probably talk for half an hour for this. So let's stop it here. But you get the idea. You need to look at the current research, the state of the art research. Not all researchers are state of the art, right? So you need to look at what are the state of the art researchers which are pushing the boundaries, and you will find a lot of things. Also look at CES videos. CES is the consumer electronics, and there you see the end result of it, and many of them will go back to the basic problems that they face to not being able to realize the end product. Yeah, so those are also a very good source of information. Next question.
Okay, yes. So I can see this is the last question here. Someone
Mhm.
asks, so what is the future of AI in chip design?
Once more.
The question says, sir, what is the future of AI in chip design?
Future of AI in chip design. So AI is used for chip design. So Cadence that you saw there, it is used for EDA, so design automation basically. Cadence was used by NVIDIA basically. So NVIDIA was basically user of Cadence to make the chip designs, and now it is other way around. Now NVIDIA provides the tools for Cadence to automate everything. So now Cadence uses AI from NVIDIA to design, be able to automate chip designing. So there are a lot of possibilities for AI to use for chip design. But the thing is that we are restricted by physics. We are not restricted by AI or those kind of things. At the current restrictions are by physics, and you can use AI for many designing and testing that will certainly help and accelerate. But the core challenges needs to be solved in the fundamental science.
Yes, so that was the questions part.
Okay.
Yeah. So that was truly an incredible session, sir. Not just a tech
Mhm.
talk, but a reality check, a motivation boost, and a Google Maps route to the future, all rolled in once. Thank you so much, sir, for being so generous with your journey, your time, and your insights. To everyone attending,
Sure.
let this be your reminder. Your dream job doesn't begin with on a job portal. It begins with curiosity, consistency, and asking the right questions. ECE will be back soon with more other sessions, more stories, and more sparks. Until then, stay curious, stay driven, and stay kind to yourself. Thanks for joining us, and see you soon.
So with
Hey,
that, I'd like to bring this meeting to a close. Thank you,
mhm.
Sumit, for your